Welcome to the Pre-Calc Summer Supplement, Part 1. Before we get started, please make sure that you have a pencil and paper and are really ready to take this supplement and not just watch it, but watch it as an active learner. Make sure that you are keeping up with the notes. Make sure that if there's anything that you do not understand, that you play it a couple times until it sinks in. I would say don't go on until you get the things that have been said. Now there will be examples to follow each definition, so you should make sure that you begin to watch the examples. Make sure that you watch these supplements from beginning to end. And then as a companion, there are practice problems with the solutions that are also on the website. So you need to make sure that you do every practice problem. The way that it's set up is there would be a practice problem given. You should try to do it without looking, and then look, and if it's too much to look at all the steps all at once, reveal to yourself just a little bit at a time so that you can make sure that when you come in ready for a pre-calc in the fall that you have mastered these concepts. And if you really are having a lot of trouble with these particular things, start off with the mindset that you will get it, and when it's presented in class, make sure that you ask questions. Anything that didn't quite make sense from these videos, please make sure that you clear those things up before you go on. So with that said, if you do not have paper, go get it. Make sure you pause as much as needed in order to keep up. Make sure that you're listening to every word, and I hope that you're having a blessed summer at whatever point that you're looking at this, and let's move right along. Our topics in this lesson, in the lesson 1, the things that you'll be able to do are rational numbers, rational algebraic expressions, multiplying rational expressions, dividing rational expressions, and simplifying complex fractions. We're going to tackle those topics one at a time with examples just to make sure that the things are making sense to you. So let's just start off by reviewing what a rational number is. If you recall, rational numbers are any number that can be written as a fraction. 3/5, that's easy because it's already written as a fraction. However, your decimals that end or terminate can also be written as fractions. They're rational, as well as your repeating decimals are also rational numbers. So we're just going to start off by taking a look at fractions, a review. Now if these beginning things seem a little bit too easy for you, that's good. But keep in mind that everything that I'm saying for a purpose, and each one of them is important for you being able to get the next thing. So if you're going along and you find yourself starting to get lost, go back to the simpler things and play it again until you get it. Alright, so let's take a look at some fractions. You know from a long time ago that rational numbers always have to be reduced to lowest terms. You need to reduce fractions. You can't leave 6/10 as 6/10 or 24/36 as that. You have to reduce them. From your past history, you know that in order to do that, you divide the numerator and the denominator by the same thing. And at this point, reducing fractions should be something that you can do easily. Now you might say, well, I always just put it in my calculator and use the math and the frac option, the math frac button on your calculator. Well, that's great, but if you lose how to do it when we work on the algebraic expressions that need to be reduced, you're going to have a problem. So you have to get this idea that what's happening is here all we're doing is dividing by 1 because we're dividing the numerator and denominator by the same thing. Here we're dividing by the same thing. Here by the same thing. So we haven't changed the value of these fractions at all. All we've done is written them in simpler form. Another way that sometimes we think about reducing fractions is to factor and cancel. Notice when you factor 6, 6 is 2 times 3, 10 is 2 times 5, and the 2's will cancel. It is always okay to cancel out factors. Notice I emphasize factors. Factors can be canceled, and I will make a big deal about that because it's important when we start to take a look at polynomials. 12 is a factor of both 24 and 36, so it can be canceled. 3 is a factor of both 9 and 15, so it can be canceled. So canceling and reducing also works. Now, you have to understand that you're canceling factors. You cannot break a numerator or a denominator down into a sum and cancel in the same way. Alright, I'll show you an example. I've already got it circle slash, so you know that it's ridiculous before I even show it, and no one would do it. But you need to keep this in mind as we go forward into these polynomial expressions, so that you don't make any critical mistakes. Okay? For example, if we tried to break this down into 2 plus 4, which makes 6, you know that you can't cancel this. Okay? 2 is not a factor of 6. 2 is not a factor of 6. You can only cancel it if it's a factor. This would give you a completely different answer if you did this. This fraction bar acts as a grouping symbol, which means this whole thing up here is a group that has to be treated as if it's stuck together. So in order of operations here, 2 plus 4 would be done first to get the 6, and then factoring and canceling works. But you could never break it down into a sum. And you might say, well, that's ridiculous. I knew that. Well, I'm making sure of this because as we move on, you're going to encounter some things that traditionally fool people. So just tuck that away for a minute, and we will get back to it. I'm going to go to the other type first, just the canceling idea first. Okay. A rational algebraic expression is when you have a quotient of two polynomials. Now remember, polynomials can be either monomials with one part, or it can be a sum of monomials. And we're going to start with the simplest type of polynomials, where you have a monomial divided by a monomial. Right here. 7 divided by 2x. Now there's nothing that could be canceled here. This one can't be simplified. I'm going to show you some other examples of polynomials here real quick before we get examples of things that can be simplified. Here's a quotient of two polynomials. This one happens to be a binomial divided by a binomial. And here's another one, a binomial divided by a trinomial, but those are all rational algebraic expressions. And what we are going to be doing is we're going to be looking for ways that we can check to see if these expressions can be reduced. Okay, not all of them can be reduced, but we need to be able to reduce them if possible. Just like all regular fractions can't be reduced, some of them are already reduced. But we need to be able to find ways to check to see if they can be and not make any fatal flaws. And this is basically what I just said. Rational expressions can be simplified. They do need to be reduced to lowest terms. And we always have to simplify as much as possible. We need to look for factors, as I made a big deal about factors, that can be canceled out. We're not looking for things that are added together to cancel out. We are looking for factors. So let's see what some of these things look like. You already know what to do when you have a monomial divided by a monomial. And know for a fact you've been doing that for at least 2 years. You've done it in Algebra 1, you've done it in Algebra 2, maybe even a little bit in geometry for review. But as a review, remember an exponent is repeated multiplication. So in this case, x is a factor 5 times. You have 5 factors of x. So that means that those factors will be able to be canceled when we have to reduce an expression. And you know this. This is nothing new, but we do need to review it because you have got to be super solid on this before the polynomials can even be addressed. Okay, so let's take a look here. We also need to take into account when you multiply or divide fractions. Some rules will apply, and we're going to start taking a look at those as examples very shortly. If you have two fractions and you multiply them, it's the same as multiplying numerators and multiplying denominators, as long as nothing in the denominator is a 0. Like I said, that's nothing new either. That's what this is saying. You multiply fractions. It means you can multiply the numerators and the denominators. When you divide fractions, it means that you have to turn the second fraction over. And then you can simplify like that. Now, if there were anything that was in common, it could be canceled out. So what that means, these facts just say that if you're going to multiply or divide, once it's turned into its multiplication form, you're going to be able to cross-cancel. In other words, cancel from either one of the two fractions that's multiplied. And I know we haven't had any concrete examples yet, but we will get to that. What this means is it's okay to cancel factors from one fraction to the other because it's really just one big fraction anyway. So let's start off with a monomial times a monomial. And a monomial divided by a monomial times a monomial divided by a monomial. So here, since this is a times, this means it's really just one big giant fraction that says 2a squared times 3b times c squared over 5b squared times c times 8 times a cubed, which means that you can cancel up and down, but you can also cross-cancel when we begin to look for those things. So first thing that you should do is look for any regular numbers that can be canceled out. So we check and see if 2 will cancel with anything. It doesn't cancel with the 5, but it will be able to cancel with the 8. So you want to take a look and do that first. Okay, cancels to 1, cancels to 4. What you're really doing when you're canceling with the plain old regular numbers is realizing that 2 is a factor of 2 and 2 is also a factor of 8. So those things get removed and the fraction is reduced. All right, the next thing that you need to do is rewrite so that these numbers are taken care of, and consider what's going on with those exponents. Okay, so we're going to rewrite this as a squared over 5b squared c times 3bc squared over a cubed, and then we're going to just temporarily break it down into its parts. Okay, here are the two things with the 1 and the 4 replacing. Then if we write this out the long way, now you know some rules about this, about how to handle shortcuts with the exponents when you have like bases, but I just want to review that with you. So a squared is a times a, b squared is b times b, c squared is c times c, and a cubed is a times a times a. What that means is we have factors. Each one of these things is a factor. So factors can be canceled. We can take anything that's found in the numerator and the denominator and cancel it out. I can cancel top to bottom in one fraction or top of one fraction to the bottom of the other. So what we'll do is we're going to slash out all the ones that are in common, A and A, A and A, B and B, C and C. And once they're canceled out, our answer is what's left. 3C is left in the numerator, 5, and there's an A left down here. There's a B left down here. There is also a 4 left. So we've got our 3, our 5, our 4. Those are all left behind. So then we can simplify that thing, and this turns into 3C over 20AB, and that is your final answer. You always want to simplify, and then you want to clean up your answer a little bit. You wouldn't leave it as 4 times 5. So we've got to be careful with all of these things. So this is the answer. Now usually the steps that were shown over on the right hand side, breaking it down into A times A, C times C, B times B, A times A times A, wouldn't be shown. Keep in mind, when you have a single variable to a power, all you have to do is subtract the exponents, and the variable then belongs wherever the exponent was greatest. This is nothing new, it's just that now we're doing it in multiplication problems instead of just one big fraction problem. So for example, we check the 3, that stays here. Check the A, here it's to the second, here it's to the third, so if you subtract exponents, it leaves you with 1A in the denominator. B squared and B, 1B is left in the denominator. C squared and C, 1C is left in the numerator. So of course that leaves you with 20AB in the denominator, and your answer is like that. The only reason that I showed that whole process with it broken down was to reiterate that we are canceling out factors. And I will say that probably about 15 or 20 more times. Factors can be canceled. And we need to keep in mind that every time we cancel, we are canceling a factor. Alright, let's take a look at another example. Now, in a problem like this, you have to keep in mind we can't forget about the power to a power rule. So hopefully some of you are already ahead of me, and you are remembering that you have to take this whole monomial to the second power. So when we do that, we end up with 9x to the fourth, y to the second, and have just rewritten everything. Alright, now you can start looking for things to cancel out. Now, as I said before, you can cancel out top to bottom in the same fraction, or you can cancel out from one numerator to the other denominator as long as you have multiplication. So let's take a look at that. Notice the first cancellation that was made here is in red. 9 goes into 3, 3 goes into 9 3 times. 3 goes into 12 4 times. So if we didn't have this other 4 to take a look at, we would just have 3 over 4. But it is okay to then look at what you have left and see if there's another way to cancel it. So 4 and 4 cancel out to 1 and 1. So we're left with just a 3 there. 3, x to the 4th, y to the 2nd, c to the 5th, over x, 1x, c to the 3rd, y to the 7th. But of course you know it's not done at that point, because then you need to look at your variables with their exponents. Now this time I'm not expanding it all out. We are going to use the subtracting rule for the exponents. So before I even go to the next one, see if you can anticipate the answer. That's a good strategy when you're taking notes in any class. If you can anticipate the answer, you're just one step ahead, and it makes it easier for you to catch up. So if you jot something down, if you're taking notes in pencil, that's also a good strategy. That way, if you make a mistake, you can erase and fix it if you find out that your guess wasn't right, but it still takes less time than waiting until you hear the whole explanation to start writing. I know that's not an issue here because you can pause, but when you're in a classroom setting, that's a big help. Okay, so when we do this, 4 and 1 gives you 3, and there's more of them up here, so x to the 3rd goes here. Y to the 2nd, y to the 7th, there's more y's in the denominator, so when you cancel out the 2 y's, you're left with 5 down here. And there's 3 down here, and 1, 2, 3, 4, 5 here, so 3 of them will cancel and leave you with 2 up here. So here's our answer. For each variable, the exponents have been subtracted and the variable appropriately placed. Alright, now if you're feeling like it's easy right now, good. It should seem like it's almost just review right now. Trust me though, we are going to be getting into the harder stuff before you're done all of this summer supplement. Okay. Now we move on to division. Division is not that much more difficult than multiplication, because the first thing you're going to do is make it into a multiplication problem anyway. Remember, the rule is that when you have a fraction divided by a fraction, it really means you change it to a multiplication sign and flip over this second fraction. You flip over the one that comes directly after the division sign. So this is what this looks like. A 5ab to the 4th came up, 2xy squared came to the bottom, and then you begin to do what we were doing before. You begin to look for things to cancel. So you go ahead and you cancel those things out. The 5 and the 15 cancel. This is a mistake because 15 divided by 5 is 3. Let me just fix that up. There we go. But this is what we do. We cancel this out. 5 cancels with 15, we get 3. 8 cancels with 2, and we get 4. So we look for the numbers to cancel, and we do that. Now, after you've looked for the things to cancel, you should always rewrite it so that now you've got 4x squared y. Get rid of all of the extra things that you've just canceled out. Then you look for things, look for variables to cancel out. Check the exponents. You're going to do your subtracting as needed. So here we have x squared and x. That leaves you with 1x up top. Y and y squared leaves you with 1y down in the bottom. b to the fourth, and b leaves you with a b cubed up top, and a squared leaves you with an a down in the bottom. So you should just always make sure that you're carefully evaluating the exponents, and this cannot be simplified any further. So there is your answer. Okay? So you're always looking for what can and cannot be canceled. Now, what we need to do is we need to move this along to polynomials. Now, you've done a little bit of this already in Algebra 2. I know that you have. And I want to make a big, giant point before we get on to the more difficult ones. When simplifying rational expressions where the numerator and denominator are not both monomials, be sure to factor first before you begin to cancel. Do not cancel when you still have the numerator or denominator not factored as much as possible. Now, one can be a factor, but make sure that you are thinking of them in terms of factors, not terms. Make sure you factor first. Make sure you factor first. Factor first before you begin to cancel. If you don't think I mean it, I mean it. Factor first. So let's take a look at an example. Here's an example, and I know you've seen it before, and I have seen people make mistakes over and over on this problem, which is why I'm taking so much time on this beginning stuff before you even get to anything new. You can't just cancel these 5s. You have to factor this numerator first. It is a polynomial. 5x squared is a term. 25x is a term. Factor them first. 5x divides evenly into 5x squared and 25x. So the first thing you're doing, 5x times x gives you 5x squared. 5x times 5 gives you 25x. Now you have factors. You have 3 factors. 5, x, and x minus 5 are all factors in the numerator. This in parentheses is a factor by itself. Okay? So, you can cancel complete factors. So, when I'm looking to see if I can cancel anything with this 5, I'm looking for another 5, which I can do up here. The 5s can cancel. This 5 and this 5 cannot. This 5 is only part of this factor. You have to cancel complete factors. Once you've done that, you get x times x minus 5 over 1, but you would never leave this 1 in the denominator. You want to clean it up to make it look as simplified as possible. So you'd put it as x times x minus 5, and that is your answer as far as being simplified. Now, I told you I was making a big deal about this whole factoring and canceling thing. So let's look at how not to do it. Okay, we know that this is the real answer. We just did the work on that. But what I had seen some of you do gives a completely wrong answer. Some people try to cancel before factoring. This answer is way different than the real right answer. You cannot just cancel a term. You have to have a factor. 5x is not a factor of the whole numerator. It's just this 5 right here is a factor of one of the terms. It's got to be a factor of the whole thing in order to cancel. It would be the same as taking 2 plus 8 and canceling the 2's and making that answer 9. You know that this would be 10 over 2. The answer would be 5. You cannot do this ever, 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 ever. You have to be super careful with them. Never, ever, 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 ever. Alright, so with that, this is the end of the introductory lesson on this. It is by no means enough to let you do all of the problems in the Lesson 1 supplement section. However, you can get started on it. The next lesson, I wanted to break them down into about half-hour sessions. So this will end this session, but we will pick up on the notes, on the information on this. So for now, you're equipped to do part of the first set of problems. You can either do that or you can wait to watch some of the other ones, but we're going to end for now and have a break, go get a snack, whatever it is that you want to do, or just plow right into the next one. But for now, I'm going to say goodbye.